Okay, welcome to the final part of this unit. We are going to study here magnetism and electricity, but specifically the connection between the two. Okay, there's a connection. That's the first thing you need to know. It's a special connection. It's between magnetic fields and not just charges, but between magnetic fields and moving charges. So underline moving. Here's one of the two connections we'll see. A charge that moves, whether through empty space or filled space, whenever the charge moves, it produces its own magnetic field. It's weird, but it happens. Whenever the charge stops moving, the magnetic field disappears. And the faster the charge goes, the stronger the magnetic field. Those field lines make loops or circles. Because all magnetic field lines cannot terminate because they don't have anywhere to end. There's no monopole, there's no north pole isolated from a south pole. So they can't end anywhere because there's no pole at which to end. So they just keep going in a circle. Now, this video is really good. It demonstrates it. It is, however, wrong. There's one small thing which is wrong. So let me go all the way to the beginning. So that right there is a charge. At the very start, it's not moving. So you don't see any magnetic field lines. You don't see any circles. But when it starts moving to the right, watch what happens. It starts moving, and now there are these field lines being produced around the charge. And check it out, the field lines make circles, they make closed loops, like we expect. And they make kind of like they make concentric circles around the charge. And then when it slows down, there we go, when it slows down, those field lines disappear. So when it stops moving, we have no more field lines. Look at all those videos. Now, a couple of things that are wrong about this. This is a great animation. There's a couple of things that are wrong. The faster the particle is going, the faster the charge is going, because this is charged now. It has to be charged to produce a field, a magnetic field. The faster the charge moves, the stronger the magnetic field. Okay? The stronger the field, the denser the field lines, the more closely spaced they are. So let's watch this video. Is it correct? Are the field lines more closely spaced when it speeds up? And are they farther spaced apart when it's not going very fast? Let's watch and see. So it's not going very fast, and those are pretty close field lines. And then it speeds up, and it looks to me like the field lines are getting farther apart. So this is backwards. The field lines should be closer spaced. So imagine like lots and lots of field lines really packed together the faster it goes. And then here when it slows down, those field lines sort of disappear and fade away. And we have wider spaced fields.